Welcome to This Explainer. Today, we are doing a complete breakdown of a full chapter on the methods of psychology. But look, instead of just reading off a list of textbook definitions, I want you to picture the psychological researcher as a detective. Because just like a detective walking into a crime scene, a psychologist is equipped with a very specific, highly refined set of tools to solve the ultimate mystery, human behavior.
So the core problem we face is a pretty tricky one. How do we actually measure the human mind? I mean, it's incredibly complex and it's completely invisible. You literally can't put a thought on a scale and you can't measure an emotion with a ruler. Because of this, psychologists have to rely on a rigorous scientific method to translate all those unseen cognitive processes and behaviors into tangible, measurable data.
To do this, we're going to unpack this chapter through 5 logical phases. First, the science of behavior, then methods of gathering data, moving on to tests and experimental methods, navigating the ethics of research, and finally, making sense of all that data.
All right, let's jump right into Section 1, the science of behavior.
The baseline assumption for any psychological detective is that human behavior just isn't random chaos. They firmly believe that psychological phenomena, how we think, how we process information, how we act, can actually be methodically investigated and measured. It's really all about swapping out our assumptions for careful, systematic measurement.
The simplest way to start? Well, just by watching. But you've got to make a choice. Naturalistic observation, like say watching people interact in a public park, gives you this wonderfully realistic picture. But there's a catch. You risk the observer effect, where subjects completely change their behavior just because they know you're watching. Or observer bias, where you basically only see what you expect to see. On the flip side, artificial or controlled observation in a lab gives you brilliant control, making it super easy for others to replicate your work. The trade-off there, the artificial setting might cause unnatural behavior, which can ruin the validity of your study. So, every detective has to choose their stakeout location very wisely.
Moving on to Section 2, methods of gathering data.
Now, when you're dealing with rare conditions or really complex behaviors, just observing from afar isn't going to cut it. Researchers will use the case history method to build a massive, comprehensive profile of just a single individual. They'll pull from everywhere: interviews, medical and school records, even personal diaries or talking to friends. It provides incredibly rich, detailed data. But keep in mind, because it's so hyper-specific to one person, you can't easily generalize those findings to the rest of the world. Plus, the information can sometimes be a bit subjective.
If your mystery involves how humans change over time, you've got 2 main options. You can run a longitudinal study, which means patiently tracking the exact same group of people for years, sometimes even decades. It's amazing for identifying real developmental changes, but it is tough. You get what's called sample mortality as people inevitably drop out over the years. Now, if you don't have decades to spare, you use a cross-sectional study. This lets you compare, say, a 10-year-old, a 20-year-old, and a 30-year-old all on the exact same day. It's lightning fast, but you aren't watching real changes over time, just differences between age groups right now.
And if you just need to quickly ask a large representative sample about their thoughts, surveys and questionnaires are incredibly efficient for that. You can gather private information super fast, but you really have to watch out for courtesy bias. This is when participants give you the socially desirable answer, like, exaggerating how often they exercise, rather than telling you their true opinion. You also risk response sets, where people just start randomly checking boxes without actually thinking about the question.
Okay, let's head into Section 3, tests and experimental methods.
Before we can even think about trusting a psychological test to measure mental attributes, it absolutely must possess 5 core pillars. Reliability means it yields the same results every single time. Validity means it actually measures what it claims to measure. Like an intelligence test shouldn't be measuring someone's anxiety levels. It also needs uniformity in how it's administered, objectivity to stay totally free from bias, and interpretability so the final scores actually make sense. Basically, without these 5 pillars, a psychological test is literally just guesswork.
Depending on the specific mystery they're trying to solve, psychologists will select from 6 main categories of standardized tests. Categorizing dimensions of character, they'll use a personality test. Diagnosing lost cognitive function from head injury, that calls for a neuropsychological test. Or maybe predicting someone's potential for learning a completely new skill, that's an aptitude test. Every single tool has a very specific use case, ranging from employee selection to individual counseling.
But what if you want to prove that X absolutely causes Y? Well, to truly prove a cause and effect relationship, our psychological detectives have to rigidly follow the 7 ironclad rules of the experimental method. You really can't skip around here. You find the problem,
form your temporary explanation, which is the hypothesis, do the background reading, randomly choose your participants to kill any bias, lock down your variables, execute the design, and then finally analyze the data and conclude. This rigid structure is exactly what gives researchers such incredible control.
The beating heart of any experiment really comes down to the variables. The independent variable is the cause. It's basically the dial the experimenter directly turns or manipulates. The dependent variable is the effect. It's the measurable response or behavior of the participant. Usually, participants get split up. The experimental group gets the independent variable, while the control group does not. Sometimes the control group might even get a fake treatment, a placebo, just to see if their own expectations alter their behavior. And to prevent bias, researchers often use double-blind studies where neither the subject nor the experimenter knows who is in which group until the very end.
Now for Section 4, the ethics of research.
Because of, well, some historical missteps in science, these 5 ethical mandates are totally non-negotiable today. First, participation must be completely voluntary. Absolutely no coercion allowed. Participants also must give informed consent, meaning they know exactly what they're getting into before you collect a single piece of data. If you absolutely have to use deception for your experiment to work, like maybe giving them false feedback about their performance, you must conduct a thorough debriefing afterward to remove any anxiety and explain the true nature of the study. You also have a moral duty to share the final results with them. And above all else, you have to maintain strict confidentiality of your data sources.
Finally, we arrive at Section 5, making sense of data.
The first mathematical concept here is defining our target. The population is every single person who meets your criteria. But since it's practically impossible to test millions of people, researchers draw a smaller, representative sample. Now, for the math to actually work, that sample ideally needs to be randomly selected so it perfectly mirrors the entire population, rather than just acting as some biased subset.
Once you test that sample and drop their scores into a frequency distribution, you basically have 2 jobs. First, you use descriptive statistics. This is exactly what it sounds like. You're organizing and summarizing the numbers to find patterns and condense the data. Second, you use inferential statistics. This is the crucial math that permits us to infer if the differences we found between our experimental and control groups are actually scientifically significant or if they just happen by random chance.
Let's look a little closer at descriptive statistics. When we want to find the exact center of our data, our go-to tool is the mean. This is simply the arithmetic average of all the scores combined. By adding up all the scores and dividing by the number of participants, the mean perfectly condenses that entire set into one mathematically average score.
But what if one extreme outlier, like, say, a billionaire in an income study, is totally skewing your average? That is exactly where you'd prefer the median. By lining the scores up in numerical order, from lowest to highest, the median gives you the exact middle point of your participants' scores, exactly half scored above and half scored below.
And finally, we have the mode. The mode simply tells us which specific score or behavior showed up most frequently in our research. But here's the thing. Knowing the center point is really only half the battle. To truly understand our results, and honestly, to critically evaluate those sensational news headlines we see every single day, we need to know the variability. Basically, how spread out is our data from that central average? The range gives us the simple distance between the highest and lowest scores. The variance gives us a number that indicates the overall spread. And the standard deviation, which is just the square root of the variance, tells us exactly how far, on average, individual scores deviate from the mean. These measures supplement our central tendency to give us a complete, highly accurate picture of the behavior we just measured.
And there you have it. We've successfully completed this breakdown of a full chapter on psychological methods. We covered everything from gathering clues in natural settings, to running experiments in the lab, to acting ethically, and finally crunching those descriptive and inferential numbers. The invisible mind is now measurable. Which leaves you at the ultimate question. Armed with this psychological detective's toolkit, what mystery of human behavior are you going to investigate first?